The motion of this rope swinger can be studied and analyzed using our rope swing lab. In lab 4, the learning outcome are 1. To understand the physics of rope swing by rock climbers, which is equivalent to the spring mass system. 2. To understand the law of conservation of energy in practical systems, ignoring the non-conservative forces like viscous drag and friction. For modeling, the swinger is equivalent to object of mass m. The rope is a gigantic spring made of parallel chains of atoms having spring-like bonds. The type of motion is two-dimensional of a system consisting of mass, spring and the earth. The three forces considered are the rope force, which is the spring force, the gravitational force, which is due to mass of the object, the kinetic energy of the moving object. These are the various formulae which we learn and use in this lab. The rope force is half ks squared, gravitational force is m into g, spring constant is 4 pi squared m by t squared, the relaxed length L0 is L minus mg by k, time period is 2 pi into root of m by k. The energy principle for the system of mass, spring and earth, delta total energy is equal to delta k plus delta ug plus delta us. These are the steps to find the energy. We use the tracker first to get and analyze the position data, which is saved in a .csv file. These are the data from CSV file. The changes in the energies are computed using the Python code. The tracker data gives the 4 experimental values, namely y, k, s the stretch, L0 the relaxed length of the spring. The Python code is run through vidle program. In the visualization and graphical setup, arrow 1, arrow 2, ball 2 positions are uncommented. In the system's properties, the values calculated from the tracker data are incorporated. In the other initializations, the values ks and L0 are incorporated. To specify the spring force vector, we include those 3 lines. To compute the system energy, we are using these formulae. The initial values of the energy, the interaction forces, and the final value of the energies are included. Then the graph is plotted as 4 plots for delta k, delta ug, delta us, and the total change in the energy. I encountered the following problems. The tracker did not run in my system. It was unable to create Java virtual machine. I used another PC, used tracker and uploaded that .csv file into my system. But the Python code showed error in the first 3 lines itself. I failed to get the graph, but I am happy that I could follow the lab and carry out all the necessary steps in the coding. I learned at least something. The results. Is the energy principle satisfied? Yes. The total energy change of the spring mass and the earth system is 0, ignoring the friction at the fixed point of the spring and the viscous drag. So, change in total energy is equal to change in the kinetic energy plus change in the spring energy. For calculating the period of oscillation, from the x position
data we first calculate t, and then from y position data we calculate it. They should tally so that the two plots, blue and red lines indicating the observed and the computational values, coincide. Thank you.